We're going to graph y equal x squared minus 6x. Okay, if you look closely, you see the leading power here of x is a 2, so that means this is a parabola, and we know it either opens up or it opens down. In our case, we know it opens up because the coefficient of x squared is positive. So this is going to be a parabola opening up. So anytime you have an equation where the highest power of x is x squared, and all of, it has x to the first power or constants, it doesn't have any crazy fractional powers, it has a polynomial with the highest power of x being x squared, it's a parabola. So you need to know the basic shape, so it's going to look like this. So let's just do a few things. Let's find the intercepts. Okay, so let's start with the x-intercepts. To find the x-intercepts, we are going to set y equal to 0. So we get 0 equals x squared minus 6x. We're going to solve this equation. To do so, let's factor out an x. 0 equals x times x minus 6. Then either x equals 0 or x minus 6 equals 0. So we have x equals 0 and x equals 6. Now, notice x equals 0 is not an intercept, because that, if we were to graph x equals 0, that's a line, that's a vertical line. X equals 6, again, is a vertical line. So your intercepts are points 0, comma, we know the x value was 0, the y value was 0, that's how we got this, so 0, 0. Here, the x value is 6, and the y value is 0. So your intercepts, we have two x-intercepts, are 0, 0, and 6, 0. Let's find the y-intercept, if there is one. Sometimes there may not be. To do so, we are going to set x equal to 0. We get y equal 0 squared minus 6 times 0, or y equals 0. So we see that y is 0. We got that by setting x equal to 0. So we get the point 0, comma 0. Do you notice anything? Do you see that the point 0, 0 is both an x-intercept and a y-intercept? Should it be? Actually, it should be. Anytime you have the point 0, 0, it will, as an x-intercept, it will also be a y-intercept, because 0, 0 is the point where the x-axis crosses the y-axis. Okay. So this is a parabola. We can just plot those points and plot other points if we want to, but let's go ahead and try to find the vertex. So there's several different ways to do it. I like to just memorize the x-coordinate. The x-coordinate of the vertex is negative b over 2a, and that's if y equal ax squared plus bx plus c. So our equation is y equal x squared minus 6x. Do you see that a is 1, b is negative 6, and c is 0? So if I'm looking for the vertex, I can use this formula. X equal negative b, so negative of negative 6 over 2 times a, 2 times 1. I get positive 6 over 2, so the x-coordinate of the vertex is 3. I'm going to scroll down just a little bit. Vertex is a point on a graph, so I need a y-coordinate as well. So if x equals 3, now we're going to plug x equal 3 back into my equation, y equal x squared minus 6x. So y equals 3 squared minus 6 times 3. Y equal 9 minus 18. That's negative 9. So the vertex is the point 3, comma, negative 9. Okay, so now I'm going to scroll down just a little bit and draw my graph. Okay, so I need negative 9 at least. Remember, the vertex is in this case, let me scroll up a little bit, we said this was a parabola opening up, so the vertex is going to be the smallest y value we have. So I just need to get to negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then 1, 2, Obviously my scale isn't quite perfect, but it's good enough. Okay, so I can plot the point 3, negative 9, 3, negative 9. I know there is an axis of symmetry going through that point. That's what the vertex tells us. So if I want to, I can draw a line, beautiful straight line, like that, through my axis of symmetry. And it should really cross at 3, but that's close enough for my work. So I know that if I have a point on this side, I can reflect it across here and get it at another point. So let's look at our intercepts. I think we had 0, 0, and 6, 0. So here's 0, 0. And you see that that's 1, 2, 3 units away from my axis of symmetry. That means there'll be a point over here, 1, 2, 3. Well, I knew that already because that was my other intercept. But we also get that from symmetry. You could also make an XY table. So I had 3, negative 9, 0, 0, 6, 0. And maybe I want to put in, I don't know, let's see if I want to put in 1. Let x equal 1. So I have y equals x squared minus 6x. If x is 1, y equal 1 squared minus 6 times 1, y equal negative 5. So 1, 1, 2, 3, 4, 5. Now that means if I go 2 away from my axis, 1, 2, the point will also be negative 5. So that's 1, 2, 3, 4, 5, negative 5. Do y'all see how I did that just by using my properties of symmetry? Well, let's check it. If I put in 5, I get 5 squared minus 6 times 5. I get 25 minus 30. And yes, that's negative 5. Okay, now I'm going to connect these in a nice smooth curve. I'm going to screw this one up, so just bear with me when I do. Okay, make that a really big point. Okay, and this is your graph, y equal x squared minus 6x.